Now we're going to look at compaction and the plant that's used for compaction. So hopefully you recognize this. This is the standard compaction curve. So you've got the soil density. Soil density, you can read that as soil strength as well. The more dense the soil is, the stronger it is, versus moisture content. So when the soil is really low moisture content, it's really dry, it can only compact to that much. As it gets wetter, it gets to a point where it's at its optimum moisture content. At that optimum moisture content, or the OMC, the soil will compact to its maximum density. And then as it gets wetter, it starts to drop away. The reason for that is when the soil is really dry, sorry, this is just for fine soils, for silts and clays. When the soil is really dry, there's no lubrication between the soil particles to allow them to move into a denser matrix. When the soil gets too wet, there's too much water in the soil air voids, in the soil voids, and the pore pressure prevents the soil particles from moving together into a more denser matrix. So at this point here, you've got the lubrication you need to allow the soil particles to move into a denser formation, but it's not too wet so that there's water pressure stopping the particles from moving together. So that's what we're trying to do. We're trying to sort of get the soil to within 2-3% of that optimal moisture content, and this just shows the phases there. The solid phase, the more dense the soil is, the more closer together these things are, the more efficiently they packed together they are. So rollers are used to compact the soil. So one of your first challenges is to get the soil to the optimum moisture content, or plus or minus 2-3% of the optimum moisture content, and then you put rollers over top of it. And what the rollers are doing is they are applying force, either static force or vibration, to the soil particles to get them to even into a denser state. And there are different types of rollers according to what the soil is and what you're doing with it. So the first one is a steel roller. All it is just very heavy with steel wheels on it, and it just rolls back and forth. It's using the weight of the roller alone to compress the soil. It compacts the top layer only, so the top maybe 200-300 mils only. It produces a hard, smooth surface, but you may end up with maybe 100 mils of really hard, smooth surface, and the 200-300 below it is soft, so it may just give you a crust rather than a complete compact layer. A vibrating roller is like a steely, but it's also got vibration as well. So it uses its weight to compact down the soil, but it can also vibrate. So inside each of these wheels here, inside that wheel there, is a eccentric weight, and it's rotating around at a high speed, which is creating a vibrating action, and that vibrates the soil particles down into a denser shape. Especially effective for sands and gravels, not very good for clays. In fact, with clays it will turn the clay to mush, so not a good idea for clays. They compact to a reasonable depth, deeper than a steel roller alone. They can be towed, walked behind, or self-propelled. This one here, you can see there's two vibrating drums, and this one here there's one with wheels there to make it faster. This one here would be very slow. This one here would be able to go a bit faster because it's got its drive wheels it's got wheels as drivers, rather than this one here has got a drum as a driver. So this next one is a sheep's foot roller, and what it does is it's good for silts and clays. So what happens here is it provides the weight to compress the soil, but it also provides a kneading action. These little feet here, when they go into the ground, they knead the clay together, so they provide lateral compaction as well as vertical compaction. Not very good for coarse soils. The feet dig into the ground initially, so you can see there's little footprints there. As it gets more and more compact, the imprints are less and less, and eventually the machine will not be leaving many footprints at all. They say that it's walked out of the excavation. So when it's not making any imprints anymore, it's compacted everything down as much as it can. The other one, it's not necessarily used for earthworks, but I've kept it here because it is about compaction. The pneumatic tire roller provides a kneading action on the soil, so it's just a whole lot of pneumatic tires rather than a steel roller. Provides a kneading action on the aggregate. That shouldn't be soil, that should be aggregate. It's not really used on soils except for just the top layer of soils, just to tighten it all up. So it can tighten it up, but usually what you use these things for is for road construction, or when you are compacting gravels or aggregates for a road construction. And the reason for that is that the kneading action sort of tips over the soil particles and allows them to sort of arrange themselves into a more a dense state.